Welcome back to TG LearnX. This is part 5 of our project-based ETABS course, where we will assign loads to our G+6 building model. And before I assign the load, here I want to remove. Here I want to remove this slab because I consider here. As per my consideration, I can consider here the staircase, and I delete this slab because here is the area of the staircase in our model. And in the previous part, we defined all load patterns. We define all load patterns here, and we define live load EQX, EQY, went in X direction, and then went load in Y direction. Now we will apply those loads to slabs, beams, and structural elements in a professional way. First, we will assign dead loads such as floor finish directly on the slab. Okay, and to do that, I come here and select. I have to select all the slabs and properties, slab sections, and I choose slab 150. Okay, then click on select and close. You can see that all the slabs are selected, and now I come here and assign floor finish loads and click on apply. Then okay, the direction is in gravity, and then click on OK. Now 1 kilonewton per meter squared applied. After that, we will assign the live loads according to do that, I come here and select here in properties slab section. Again, I want to apply the live load on slabs. I choose slab 150. Then here I'll assign the live load. Come here in shell load, add to existing load. And for rooms, it is 2 kilonewton per meter squared. For corridors or staircase, it's 3 kilonewton per meter squared. And for rooms, it's 2 kilonewton per meter squared, the live load. And direction is gravity, okay, and choose apply. Then now we already applied the finished loads on our slabs and also the live load on our slabs. Now we apply the wall loads on our beams, and to do that, first I select all the beams in frame sections. In frame section, beam 450 into 230, and click on select. Then you can see that all the beams are selected. I consider here the walls on all the beams, but you can do it according to your layout plan. Suppose that there's not any wall in this beam, and you can only select those beams that have the walls load on it. And as per my consideration in this model, I consider the walls on all the beams here. And to assign the wall loads, come here and assign. After selecting the beam, we come here and assign and frame loads and distributed. Okay, distributed. Now we know that it's a dead load, and that is forces, direction is gravity, and click add to exist. To find the uniform load, we have to multiply the thickness of the wall into the height of the wall. The height of the wall after removing or not considering the depth of the beam. Depth of the beam is 450, and if we remove 3 meter from 45 centimeter, then we will have 2.55 meter height of the walls, and we have to multiply this one into the specific width of the breakworks, and the specific width of the breakworks is 80 kilonewton per meter cubed. Then we hit enter, and we will have 10.5 kilonewton per meter the wall loads on our beams. And you can also remove the windows or consider the area of the windows and don't calculate it here, but I consider here all the walls like this because in this model we want to learn you how to use this software to design a building, and after you know how to use it, then you can do it as per your layout, as per your drawings, and know how to use this software. So I found here 10.5 kilonewton per meter the wall loads. Then click on apply, and this loads will be applied to all our beams. Then click on apply, and also you can see that in all beams 10.5 kilonewton per meter is already applied. Now we have to assign the staircase load on the landing beam and also the landing slab loads on the landing beam. That's very important. And to calculate it manually, here I have to explain it for you how you can calculate the landing slab loads and also the staircase loads. And to do that, we know that if this one is our landing slab, and here we have our beams landing beam. Here, if we have our landing beam, this one is our landing slab, and here is our staircase. Here's our staircase, and we know that the staircase, choose this one, the staircase or the waist thickness is 0.15 meter or 150 millimeter is the thickness of our waist, and we have to multiply this one into the specific weight of the concrete into 25, and this will become 3.75 kilonewton per meter squared. Kilonewton per meter squared. And we have to change this one into distributed load, and we have to change this one to kilonewton per meter. And to do that, we have to multiply this one into the width of our staircase, and I consider the width of our staircase 1.2 meter, and we multiply this one into 1.2, and we will have, if we multiply 3.75 into 1.2, then we will have 4.5, and we add the finished load 1 kilonewton per meter, and also this is 1 kilonewton per meter squared, and we have to multiply this one into the width of our staircase, then we will have 1.2. Because this loads will transfer to the landing beam, we have to change it into distributed load, not as area load or shell load. And then we will add live load. This one is the dead load. We will add the live load 1 kilonewton per meter squared and multiply to 1.2. Then it will also 1.2. If we add these three, 4.5 plus 1.2 plus 1.2, then we will have 6.9, and I consider it 7 kilonewton per meter is the load of this staircase. And we have to also find the loads of this landing slab, and apply the total this 7 with this landing slab load onto the landing beam. To do that, here the width of our landing slab is, I consider, 1 meter, and the thickness of this slab is 0.15, and we have to multiply 0.15 into 25 into 1. 0.15 into 25 into 1, 3.75. 3.75 kilonewton per meter with this one plus 7 will become 10.75, 10.75, and I will consider it as 11. Okay, 11. And we have to apply this 11 onto our landing beam. We have found earlier the loads of the staircase and landing slab on the landing beam. Now we have to assign the loads on the landing beam. This one is our landing beam. The staircase will start from here, and here we have a landing slab that's on this beam, and here also we have a staircase. And to do that, we select the landing beam and go to the assign frame loads, distributed, and here 11 kilonewton per meter. Direction is gravity, add to existing load, and this is that is dead load, and I assign that one. And you can see that the loads here, if you click on this beam, you can see we have 10.7 of 10.55 we have 10.5 kilonewton per meter the wall loads, and also 11 kilonewton the staircase loads. And this is not the same for this beam. This only has the wall load. And I have to mention that correct load assignment is extremely important because ETABS analysis and design results depend entirely on the loads we apply. And overestimating loads leads to uneconomical design, while underestimating loads can cause unsafe structure. And be with me. Don't forget to subscribe to get notified about the next part. Have a good day. Thanks.